There's a mountain in Northern California that some folks believe is a portal to another dimension. Now, it's getting watched for a completely different reason. Officially, Mount Shasta is quiet, the volcano alert is normal, and the aviation color is green. But satellites 400 miles up have uncovered a secret it's kept for decades. The ground west of the summit is rising, slowly, a few millimeters every year. The United States Geological Survey rates this volcano as the 5th most dangerous in the whole country, higher than almost any other peak in the Cascade Range. And get this, in January of 2024, scientists actually mapped what's hiding underneath it. A magma reservoir so huge, they nicknamed it Bigfoot, packed with up to 360 cubic miles of molten rock. That's enough magma to fill the Grand Canyon. Twice. The official papers paint a calm picture. The ground itself tells a story of pressure. Seriously, tell me in the comments right now which one you think is telling the truth. But here's the kicker, the detail that tells you everything. The last time this volcano definitely erupted was in 1786, seen by a French explorer from a ship in the Pacific. That means it's been quiet for over 2 centuries. For a volcano that's blown its top, on average, every 250 years for the last 3,000 years, that silence isn't comforting. It feels like a borrowed peace. Over 100,000 people now live and travel through its immediate danger zones every day. Most people who watch these kinds of reports don't realize how much we're actually tracking until it's too late. They see a headline but miss all the actual data that's giving the real warning. Don't be that person. What we're about to talk about isn't in public statements. This is information you only get by connecting dots across decades of data that wasn't always obvious. You really need to stick around for this. Hit subscribe now. It's that important. Let's get into it. The timeline is what really freaks out the scientists watching this mountain. This story doesn't start with a bunch of earthquakes or a puff of steam. It begins in silence, with data that folks didn't even understand until years after it was collected. In the late 1990s, European satellites using something called interferometric synthetic aperture radar, or INSAR, started mapping the Earth's surface with insane precision, way more precise than any human eye could ever be. These radar pulses measure the distance from the satellite to the ground down to the millimeter. By comparing images over time, they can actually see the ground breathe, and west of Mount Shasta, the ground was drawing a breath. By the early 2000s, analysts looking back at this archived data spotted the pattern, not right on the peak, not on that famous snow-covered cone everyone recognizes. The movement was happening in a wide circular area of forest and rock several miles to the west. A dome 15 miles across was slowly, steadily being pushed up from underneath. The speed was almost impossible to notice. 2 to 3 millimeters a year. That's like adding the thickness of 2 dimes, stacked up to the landscape over 12 months. You couldn't feel it, you couldn't see it, but the satellites did. By 2015, a clear study came out in the journal Geosphere. The authors, Christopherson Poland, and their team laid out all the evidence. They confirmed the uplift was real, constant, and had been going on since at least 1996. They traced it back to something deep in the Earth's crust. This wasn't some shallow pocket of gas or water. This was pressure from the volcano's deep core. Magma, pushing into the crust 14 miles down, was shoving the whole region upward like a piston. This discovery made people rethink the volcano. It wasn't just a sleeping giant. It was a giant that was actively, measurably refilling. Just think about that for a second. A force deep underground is permanently changing the surface of Northern California, and the only reason we know about it is because of radar pulses from a satellite way up in space. What else are we missing? What other movements are happening just below what our tech can pick up? Let me know what you think in the comments. We really need to talk about this. The USGS reacted by putting in a bunch of high-precision GPS stations and more seismometers all over the volcanic area. These instruments backed up the INSAR data. Year after year, the ground kept rising slowly but surely, a centimeter every 3 or 4 years, a foot in a century. The official statements from the California Volcano Observatory, or CALVO, kept sounding reassuring. They explained that this kind of slow inflation is normal for a big, active volcano that isn't currently erupting. The volcano is alive and well. It's a sign that the deep system is working as expected. But for the people living at its base, words like alive and recharging hit a little differently. Now, add in the discovery from 2024. Researchers from the University of Southern California, with Paul B. Dawson leading the way, used a new seismic imaging technique. They listened to echoes from distant earthquakes as they traveled through the crust under Shasta. By seeing how those seismic waves slowed down, they could map out areas with partially melted rock. What they found was mind-blowing. A giant, previously unknown magma body stretching for miles under the surface, way bigger than the volcano itself. It holds anywhere from 120 to 360 cubic miles of magma, with about 10 to 15% of it melted. This wasn't just a small chamber feeding the volcano. This was the main source. the mother lode, a huge, ancient feature that explained not just Shasta, but the entire volcanic history of that region. Dawson's team nicknamed it Bigfoot as a nod to local legends, but this monster was real. This discovery didn't change the alert level, it didn't cause evacuations, but it completely changed how we understand that 2-3 millimeter uplift. That slow rise wasn't just a weird curiosity anymore. It was the visible sign of a massive, simmering engine. A system that can create the biggest stratovolcano in the Cascade Arc was still pushing pressure into the crust above it. The diagnosis hadn't changed, but our understanding of the problem went to a whole new level. If you know anyone who travels through Northern California or has family there, they need to see this. Share this report. This isn't about being scared. It's about knowing what's going on. The first step to being safe is understanding the actual data-backed risk. And hit that like button. It tells the algorithm that this information is super important and needs to be seen by more people. Okay, let's zoom in. Imagine looking at the planet and then dropping down into the American West. Find the spine of the Cascade Range, that line of fire stretching from British Columbia down into Northern California. Go past Mount Rainier, past Mount Hood, past Crater Lake, and there it is. A white-robed giant sitting pretty over the landscape. At 14,179 feet, Mount Shasta isn't just a peak, it's practically a living thing. It makes its own weather. It cradles 7 glaciers. It's a jumble of 4 overlapping volcanic cones built over more than 500,000 years of angry eruptions. The youngest cone, Hotlam, makes up that perfect summit we see today. From Interstate 5, it looks calm, permanent, a fixed point in a busy world. Cars and trucks zip by its feet like a metallic river, their drivers often glancing up at this iconic landmark. Now, let's zoom in even closer. To the small towns clustered at its base. Mount Shasta City, with its 3,200 people, sits on its southwestern side, a magnet for tourists and spiritual seekers drawn to the mountain's energy. Weed, California, home to 2,800 folks, is just northwest, its name a relic of the old logging days. McLeod, another historic mill town, is tucked away on the southern slope. These aren't far-off suburbs. These are communities built right on the leftover debris from past eruptions and mudslides. Their water comes from the mountain's melting snow. Their economy depends on its beauty. Their very existence relies on its continued quiet. Picture this: a cashier in a crystal shop on Mount Shasta Boulevard on a bright July afternoon. Tourists wander in and out buying polished rocks and books about the mythical city of Telos inside the mountain. She looks out the window at the peak, a view she's seen her entire life. It's beautiful. It feels eternal. She doesn't feel the ground under her feet rising by a tiny fraction of an inch. She hasn't heard about the 2015 geosphere paper or the 2024 USC magma discovery. She knows the mountain is a volcano, of course. Everyone does. But it's a history fact, like the gold rush, something that happened way back when, not something that's happening right now. Behind her, on a shelf, a little seismograph trinket just sits there. A novelty item. 14 miles below her feet, the pressure keeps building. The rock is still stretching, and the real story isn't being written in crystals, but in millimeters. I know I've said it before, but if you haven't subscribed yet, you're only getting a tiny snapshot of a much bigger movie. You're missing the whole picture we're putting together. Each of these reports connects to the next one. That's why our subscribers are the most informed viewers on this platform. This isn't just entertainment, this is really important context. Just take a second and hit that button. Now, let's stack up the different dangers. The threat from a volcano like Shasta isn't just one simple thing. It's like a domino effect, where one event triggers the next. First, and this is huge, the lahars. Most people worry about lava. Lava is slow. You can usually walk away from it. A lahar is a totally different monster. It's a volcanic mud flow, a fast-moving mix of melted ice, snow, ash, and rock, thick like wet concrete. Mount Shasta has a crown of ice, with 7 named glaciers holding billions of gallons of frozen water. An eruption, even a small one at the summit, wouldn't need to be huge to cause total chaos. It would instantly melt a massive amount of that snow and ice. That water would rush downhill, picking up all the loose volcanic rock and soil on the mountain's steep sides, turning into a thick, unstoppable flood. These lahars would funnel right down the existing river valleys, the McLeod, the Sacramento, and the Shasta rivers, straight toward the towns. Models from the USGS show that a big lahar could hit McLeod in under 30 minutes. It could swamp parts of Mount Shasta City in less than an hour. These flows can travel for dozens of miles at highway speeds, burying everything in their path under rock and mud that sets like concrete. This isn't just a flood, it's a piece of the mountain itself, moving. And, considering the volcano's history, this is the most likely and deadliest danger for the region. Second, the pyroclastic flows if the eruption is more explosive, like Mount Mazama's Big Blast or Mount St. Helens in 1980, the danger cranks up even more. A pyroclastic flow is a superheated avalanche of gas, ash, and rock fragments that can hit over 1,500 degrees Fahrenheit and move at hundreds of miles per hour. It wipes out everything it touches. Shasta is enormous at 85 cubic miles, totally dwarfing Mount St. Helens. An explosive eruption here would be a regional disaster. The area of complete destruction would stretch for miles from the summit, instantly vaporizing forests and anything else in its way. Shastina, that prominent secondary peak on Shasta's west side, was the source of massive pyroclastic flows about 9,500 years ago, proving that even the smaller vents on this complex monster can be incredibly violent. Third, ashfall. That 1786 eruption, the one La Perouse saw, was notable because it sent a plume of ash far out over the Pacific Ocean. A modern eruption, even a moderate one, would shoot a column of pulverized rock, glass, and silica tens of thousands of feet into the atmosphere, right into commercial flight paths. The entire West Coast aviation industry would shut down. That ash would drift for hundreds, even thousands of miles. Just a few inches of it is enough to collapse roofs. It's so abrasive it can destroy car engines. It pollutes water supplies and farmland. A big eruption at Shasta wouldn't just be a Northern California nightmare. It would cause a national economic and logistical crisis. The winds would carry that ash eastward, across Nevada, Utah, and beyond, leaving a gritty reminder of the power unleashed. Fourth, collapse. The mountain isn't just one solid chunk of rock, it's a huge pile of its own eruption debris, steep and not very stable. A big earthquake or new magma pushing into the mountain could trigger a flank collapse, where a huge chunk of the mountain simply breaks off. This could happen even without a major eruption, creating landslides and mudslides that would be just as deadly. The mountain is constantly being weakened from the inside by hot fluids, acidic gases, and hot water that rot the rock and turn it into soft clay. That beautiful, solid-looking peak is actually a pretty fragile structure, and the same forces that built it are actively trying to tear it down. What happens next is the big question mark. Nobody has the answer. The official alert level is still green. The California Volcano Observatory and the USGS emphasize that a future eruption would almost certainly come with clear increasing warning signs. Earthquake swarms. Rapid ground changes measured in centimeters per day, not just millimeters per year. Big changes in gas coming from the summit. None of those things are happening right now. There's no emergency. No evacuation order. There's just the slow, steady rise of the land, the confirmation of a massive magma engine deep underneath, and the longest quiet period this volcano has had in its recent violent history. The statements from geologists are very careful. This slow refilling process could go on for decades, even centuries, without an eruption. It's just how a living volcano behaves. But that scientific calm is hard to swallow when you look at the data. The system is loading up. The spring is getting wound tighter. For how long? Okay, this is absolutely the last time I'll say it, I swear. Maybe. It sounds like I'm joking, but our subscriber rate is actually way lower than our view count, and these reports take a ton of work to put together. If you've made it this far, you're one of the few who really gets the whole picture. So seriously this time? Hit subscribe. The next report connects Shasta to the Long Valley caldera, and you definitely don't want to miss how those pieces fit together. The questions keep piling up. Why has this uplift been so steady for so long? What's the breaking point for the crust? How many more millimeters of rise are left before the rock can't bend anymore and starts to crack? What does it mean that the area of uplift isn't under the main summit but to the west, closer to the secondary cone of Shastina and the populated I-5 corridor? How do you get tens of thousands of people out of there when the most likely warning will be a seismic roar and the first sign of disaster is a wall of mud and rock already moving at 80 miles an hour? The people in these towns live in the shadow of a mountain they love, a symbol of beauty and myth. They're living on top of the fifth most dangerous volcano in the nation, a volcano that isn't dormant, isn't dead, but very much alive, a volcano that's breathing. The gift shops in Mount Shasta City are still selling stories about a peaceful, mystical mountain. Hikers are still walking its lower slopes, completely unaware of the forces at work. Trucks are still rumbling down I-5, their drivers taking quick glances at that perfect snow-capped cone. And 14 miles below the quiet Northern California forest, a magma reservoir larger than a national park is still there. The satellite radars are still watching the ground swell millimeter by millimeter. The seismometers are still listening for that first crack. And the mountain is breathing in.